I'm going to show you how you can use your graphics display calculator to work out the size of the sample space given a binomial distribution. And I'm going to use an example from the textbook in order to do this. It's question 7 from exercise 14C, I think. I'll read it out for you just in case your eyes are full of tears from, the joy of doing more maths videos. Monique is practicing goaling for netball. Didn't know that was a verb, neither does Google Docs by the sounds of it. She knows from past experience that her chance of making one shot is about 70%. So each time she makes a shot, she's got a 0.7 chance of getting a goal. Her coach has asked her to keep practicing until she scores 50 goals. How many shots would she need to attempt to ensure that the probability of scoring at least 50 goals is more than 0.99? In other words, she can feel confident that there's a 99% or greater chance that she will have scored 50 goals by a certain number of shots. You can see in blue here, I've started to point out what the problem is. You've got X being the random variable that describes the number of goals, not number of shots, that Monique scores. You've got X is distributed binomially with N trials and P. And N is the thing that we need to try and figure out what it is. In other words, how many trials, a trial is taking a shot at goals, a trial, so N equals what? We don't know, so we're trying to figure out how many trials. The probability is 0.7. Each shot has a 70% chance of success of getting a goal, 30% chance of failure, not getting a goal. And then you can see I've articulated that as a probability statement. We want to find out the probability of X greater than or equal to 50 so that the probability is greater than 0.99. So that's the frame up. And before I show you how to do it under a graphics display calculator, let me show you the answer and let me show you what it looks like as a probability distribution graph. Okay, so here is the question from the textbook, and the answer is 86. Okay, let's have a look at it under the graphics display calculator. So, plug this random thing into the calculator, I get 86 out of it. If you want to pause the video and have a look at these values here, it might give you a bit of a hint as to how it all works out, but I don't expect you to. All right, so let's have a look at it as a probability distribution graph, given that we know the answer is 86. Given that the answer is 86, this would be the probability distribution graph. You can see there's a big old tail here, then it goes up, then it goes down. I wonder if you can remember how to describe this graph. Is it skewed left? Is it skewed right? Or is it symmetrical? Take a moment and answer that. Something else you can get off the graph is that it has a mean of 60, roughly 60. The mean is always in the center here. If you calculate it, I think it's 60.2. So expected value is 60.2. And that kind of makes sense because if I go 86 trials and I multiply that by 0.7, I get 60.2. So that makes sense. But we're not here for that. We are here to talk about how the heck do we work out this confidence of 0.99, 99%. So what you need to remember is that this graph represents every single probability outcome from 0 to 86. We just can't see the ones over here, and we can't see the ones over here. They're too small for to show on this screen, but they are there. If I added up every single value here and these values here, I'm talking about the y coordinate, right? All of these would add up to 1. If I look at here, this means the probability of getting 50 exactly is what, half of 0.01 by the looks of it? And then 51 is 0.01, and then so on. If we added up everything from 50 onwards, we would get an overall probability of 0.99. Okay, so this up to here and down again is 0.99 if we added up all the y coordinates, all the probability values. Okay, so this is what we're going to do. We're going to use our graphics display calculator to work out what that number of trials is. However, the graphics display calculator only looks at lower boundaries. It looks at goes from the left. It goes from 0 up to a value, not from a value to the end. And that kind of makes sense in terms of we don't know what n is. I mean, I've graphed it here because we cheated and looked at the answer, but we don't know what n is, and therefore we don't know how many trials would be required in order to get to the value that we're looking for. So, which is 86. So, what we do is we use our understanding of complementary events. If it is 0.99 to go from here to there, then from 49 backwards, there's just 0.01. So if we can solve the problem, how many trials would give us 0.01 probability of getting 50, then we're cooking with gas, right? This is what we're looking for. Okay, so that's what we're going to do. Under menu, we tap 5 for probability, 5 for distributions, and we could scroll down, or if you've used it often enough, you know that D gives you the inverse probability by n, inverse binomial distribution by n, like so. You're asked to put in the cumulative probability. Again, we're looking for the left-hand side, so it's 0.01. Probability of success is 0.7, 70%. And the number of successes we're looking for is 49. It is to the left of 50. And because this is a discrete random variable, there's nothing between 49 and 50. So 49. And if you want to, you can tick matrix form. Okay. 0.01, 0.7. Hope that makes sense. 49. Looks the same as that one, but there's a 1 on the end of it, which gives us 2 possible values, just so you can see how it's approaching it. So at 85 trials, we've got 0.01 and a bit more. So that's not there yet. And then at 86, it's the first whole number that gets us below 0.01. So the number of trials is 86. And that's the answer to the question. I was about to stop the video, then I thought I might just finish by saying, just to make it really clear, this x-axis is the number of successes, of course. Okay, so 0 successes, up to 50 successes, up to 60 successes. So that means 60 goals. The reason why I said it goes to 86 is because the maximum number of successes you can have if the trial number is 86 is, of course, 86. You can't have 87 successes. So it does give us broadly the domain or the interval length of the number of successes, because you can have at least 0 successes, and you can have at most 86 successes. So that's what that axis means.